Hello, I wanted to talk a little bit about union and intersection. And I think we often jump to conclusions, and there are various cases, even special cases you might call them, to consider when dealing with the union or intersection of some intervals. So I'm going to present first just two sets of intervals, and we'll look at the union intersection, and then we'll talk about a more generic, all the different possibilities, so that you can see that there can be some special cases, and that there really are 6 cases that you can come up with. So you have to pay attention to what it says and not just what you want it to say or think it might be asking you to look at. So here we go. So here I have the set from 3 to 7, including 3 and excluding 7 in pink. And in blue here I have the set from 5 to 12, excluding 5 and including 12. First off, A, intersection B, where do they intersect with each other? Where are they overlapping? Is this region between 5 and 7. Since it's an open dot, the blue set B endpoint is not included, and it's not included here. So when we look at where they're included for both, it's on one but not the other, and so it's not going to be in both. So you would have open dots at 5 and 7. What they do share in common, their intersection, their overlap, is between 5 and 7. So with interval notation, you could express it as parenthesis 5 comma 7 parenthesis. For A union B, you're trying to unite the two sets. You're merging them together. So if I dropped the set B here down, I would see the pink starting here, including 3, and it would keep going, and this would be dropped down here all the way to 12, and including 12. So it's, if I merge them together, every single point from 3 to 12 inclusive would be part of the merging of the two, the union of the two. So closed dots have the brackets. So bracket 3 comma 12 bracket. And again, with interval notation, order does matter. And when you're doing these, notice that I do it like a normal number line. I didn't put 3, then 7, then 5, then 12. I put it as a number line because that's what it's representing. So as far as other special cases, we have over here the union and intersection. And when we're dealing with making our two cases for an absolute value, if it's greater than or equal to, you do the or, and I remember that by great or than instead of greater, great or, and for the less than or equal to, we would be looking at the and. So you'll see the or versus the and really does matter when you look at this document. So the or, the union, it either is in this set or in that set, or it could be in both. It's where you're merging. So I have two intervals in opposite directions here. When we merge them together, that's what we have. And for interval notation, you'd use the U symbol, and if you were writing this out, you would use the word or. You'd say X is less than A, or X is greater than B, if you're writing it in inequality notation. And you could also have your intervals going in the same direction, and so when you unite them, it's all the way from here to here is part of one or the other or both. So I call this left-hand side kind of my scratch work, and then I really delve deep into what is the meaning of union. So I'm merging them, I'm uniting the two together into a single representation, a single region that expresses it if possible, and if not, then we use the word or do the union. So here when I'm looking at uniting these together, when I smush them down into one inequality, it's everything. So this is often called a special case because it's everything. When we're looking at intersection, we're looking at where do they overlap? What do they have in common? And when we have them in going in opposite directions, there is no overlap. So your scratch work, if you have this situation, is going to tell you that there is no solution. So that's often the other special case. You know, everything or nothing are the special cases. And for your graph, you really couldn't graph anything because nothing is a solution to that. So, you know, if we're finding the overlap of something that's less than 2 and greater than 5, well, there is nothing that is going to meet both those conditions. No number is less than 2 and greater than 5 simultaneously. If there is some overlap in the region, then it's just from the overlap on. If they're going in opposite directions, again, you're just looking at the overlap. If you have open dots versus closed dots, you do have to be careful with your use of brackets versus parentheses. I was pretty consistent here in just using open dots, but had this been like a closed dot, then it's also closed here, and so the intersection would be closed for both, and so then it would be closed and it would have a bracket. So there are you know, nuances to the open and closed dots, but I wanted to just mention that there are 6 cases, and when you see this situation where they're going in opposite directions, it is sometimes that you write it as a disjoint, and sometimes that you're going to say no overlap. It depends if you're looking at or and. The union and intersection have very different meanings, and you have to respect that. So I hope that helps, and good luck.